Hey everybody, this is Mr. Storm. In this video, we are going to learn how to create one of the first video games ever. You're going to be able to create it in, I don't know, let's say hopefully half an hour. We'll try to keep this as short as possible. Now in this video, I'm not going to explain most of what I'm doing. I'll give a little explanation, but I'm not going to get too deep into it because at this point, you've already done pretty much everything we are going to do to make this game. I just want to show you, and I want you to show yourselves, that you can make other games than just the spooky maze that we've been working on. All right, so I've created a new project in Unity. It's a 2D project. I've called it New Pong because I have a bunch of Pong games already. And I think the first thing I want to do is I'm going to organize my assets here a little bit so that it's easier for me to find stuff, and I want to bring in my sprites. So I've created a couple of like 5 different sprite assets that we can use for this project. I'm just going to go ahead and grab them and bring them in. But first, I really want to create a sprites folder. And inside the sprites folder, I'm going to bring in my Pong sprites. Okay, and I'm not sure why I'm running 2019. Oh well, whatever. It's an older version of Unity. Things may be a little different. I guess I didn't change. I was messing around with something. Whatever. It's not important. It doesn't matter. Anyway, so I have my Pong sprites here. Now, obviously, we want to fix these so that they look good in our project. These sprites were all created for 1 pixel per unit. This is a very simple game, so we don't need a lot of high definition graphics and all that. It's not based on like 16-bit pixel graphics. These are literally just like the ball itself is a single pixel. So let's just create it at 1 pixels per unit. We're going to change our filter mode and we're going to turn off compression and we'll hit apply. Now I've selected all of those by clicking the first one, holding shift, and selecting the last one in the range, and notice that all of them are selected. And with all of them selected, I can change those options on all of my art at one time, so it kind of speeds up the process. Okay, perfect. So next, let's build the bounds of our game. So notice we have a horizontal wall segment and a vertical wall segment. I'm going to bring out 2 of my horizontal walls. And yes, they are way bigger than the camera. We're going to adjust the camera in just a second. I'm going to bring out 2 vertical wall segments. All right, that is not that is not a great looking box there. So let's go ahead and fix it. First, with these vertical wall segments, we want these to be at 0 on the Y because that'll center it vertically in my project. And if I set this other one to 0 on the Y, then they'll be exactly on the same vertical. And we want the top and bottom to be at 0 on the X, so they're exactly in the middle of the scene. Okay, perfect. Now I'm going to grab my move tool up here, and I'm just going to kind of position these where they should go. And actually, I probably shouldn't have grabbed it like that because I just took it off of 0. So instead, what I can do is just use this to kind of push it where it wants to go. That's a better way to do it. For those of you who don't know, if you click on an option in the inspector, you can drag back and forth to change the values. And so for this, I'm going to push that over there, make it nice and neat. And for that, I'm going to push this over there and make it nice. All right, so now we have to fix the issue with our camera. Our camera is very, very tiny, and it's in the middle of our game. It's not showing the whole thing. So let's grab our main camera, and let's make it a bit bigger. So we'll increase the size here so we can see the whole thing. And I want to change the background color. I don't like this blue for our old school game. I actually want just a solid black background color. I think that looks a lot nicer for Pong. Okay, perfect. So now that that's done, let's go ahead and add a collider to all of these wall segments so our ball can't just fly out of the game. So to do that, I'm going to select the top wall in my hierarchy. I will hold Shift and click the bottom wall so I have them all selected. And now I can click Add Component, and I can search for a box collider. And so it's going to add a box collider to all of those walls, so now it has collision. Perfect. Okay. Now we need to let's put something in the middle here. So I've created this dotted line segment, which is basically going to be in the center of our game, and it's not going to have a collider. It's just a way to break up the left half from the right half. And we can put this at exactly 0 on the X and 0 on the Y, and it'll be perfectly in the middle of our game. Okay, so now our level is actually built. Pretty simple. Now we need to actually get some rackets moving around in our game. So I'm going to grab a racket and bring it out and put it roughly in the middle of our project. I'll put it at 0 on the X, and we'll say, I don't know, negative 20 on the X. So 0 on the Y, negative 20 on the X. That sounds about right. Okay, now this racket is going to need a collider because the ball needs to bounce off of the racket. It's also going to need a rigid body because we're going to need to move this racket up and down. So it's going to need a rigid body. We need to make sure we turn off gravity scale. And we want to freeze rotation on the Z so it doesn't rotate when it gets hit. Okay. All right, what's next? Well, I think at this point, the only other thing we need for this racket to move is a script. So I'm going to go into my assets folder. I will create a new folder. I will call it scripts. We're going to have 2 scripts for this game, and we're going to write the first one here in just a second. So inside my scripts folder, let's create a new C# script, and we will call it racket. Okay, and then let's go ahead and open up racket in Visual Studio. Alrighty, okay. So for this racket to move, we need to do some of that movement stuff that we did before, where we bring in a reference to the object and all of that stuff. So first, let's create a reference to our racket. So private, rigid body 2D, and we'll call it racket. And we'll say racket dot racket equals get component. There we go. Rigid body 2D. Okay. So now we have a reference to our racket. So now anytime we want our racket to do something, we can just use the keyword racket. Okay. Now what we need to do is we need a speed variable. So we'll make a public variable, float speed. And I'm going to set this equal to 30. Now, if you're wondering why is it so high, well, it's because our dimensions are completely different from how they were in our previous game. Our previous game was set so that each unit was 16 pixels. This is set so that each unit is 1 pixel. So we need to, the numbers are going to be a bit off when it comes to this stuff, right? Okay, so 30, and we can adjust that as we go because it's a public variable. The other thing that we're going to need is we want to get a string that allows us to type the name of the axis we want to control. And we're going to do, let's say, vertical for this first one. Now, this is going to make sense when we make our other racket. Basically, we're going to make this a 2-player game. So we're going to have 2 different vertical axes, so that our players can each use different keys on the keyboard to control their respective racket. All right, so our variables are out of the way. So next, what we want to do is we want to actually handle our movement. So let's do, and actually this update method is fine, but we're getting into some more physical stuff. And usually fixed update is a lot better for physics movement. So I'm going to use fixed update. All you have to do is type fixed in front of update, and it will recognize it as a method that Unity understands. Okay, now we want to get into the actual movement. So first we need to get the input from the axis that we're using. So float v equals input dot get axis raw. And then the axis we're going to get is this axis variable up here. So we can just put in the variable name. So now depending on which axis we're accessing, we're going to get that value. Then all we need to do is racket.velocity equals new vector 2. And we do not want to move horizontally, right? So we're going to set 0 for the horizontal movement, and vertical movement is going to be v, and we will say times speed. And believe it or not, that's all we need to do to get our racket moving in our game. So I'm going to click Attach to Unity and let that load. There's no errors down here. I will hit Stop. Now over here in Unity, I can see that my racket script has brought over all the changes I've made. So the only thing I have to do is click on racket here and add my script to my racket object. And so we have speed 30, axis is vertical. Let's give it a shot and see if it actually works. So I can use my up and down keys, or I can use W and S to move my paddle, my racket, up and down. Now let's talk a little bit about the Unity input system, because this is going to be important if you want to make two-player games or change the input key bindings for your players. So let's go to Unity, or let's go to Edit, let's go to Project Settings, and let's go to the Input Manager. So we have our axes here. Now notice that I already have a vertical axis. By default, Unity will give us a vertical axis. And the vertical axis is what I'm using for the axis to control our racket here. And this vertical axis has a negative button, which is down, a positive button, which is up, an alternate negative button, and an alternate positive button. So these 4 buttons will control my racket. What I want to do is I want to get rid of these alternates here and change them so that the negative button is S and the positive button is W, which means I will no longer be able to use my up and down arrows for this axis. But what I can do is I can duplicate this array element to make another vertical, right? So now I have 2 vertical axes. I'm going to call this vertical right. And then I'm going to change the negative and positive to down and up. That means we now have 2 vertical axes that we can control, and we're changing the keys that we're going to use for each independent axis. Okay, perfect. So now what I can do is I can duplicate this racket. If I right-click, duplicate, I can move this racket over. And actually in here, let's set it to 0 on the Y and positive 20. So it's in the exact same spot, just on the other side. Then down here, instead of using the vertical axis, we're going to use vertical right, that new axis we just created. And I'm going to hit play just to make sure that my control scheme works properly. So up and down on the arrow keys will move that paddle, and up and down on the W and S controls that one. So now we have something of a 2-player game where one player can control the right paddle and the other player can control the left paddle. All right, perfect. We're moving along here. We're doing good work. And it's only been 15 minutes, so I think we're on time. We might be able to finish this in a half an hour. Okay, the last thing we need to do in this game is we need to bring out our ball. So the ball is going to be a bit tricky because the ball needs to be able to interact with these paddles, but it also needs to be able to reflect off the paddles in a certain angle in order for the game to be interesting. If it was just bouncing back and forth, it really wouldn't work very well, right? So let's bring out our ball and let's start setting it up so that it works the way we want it to. First, we're going to need a rigid body 2D, obviously. Let's set the mass to something very tiny. We don't want this to push our rackets around whenever it bounces. So we'll set it to like 0.001, just to make it really small. Obviously, let's freeze our rotation. Let's set our gravity scale to 0. Now, the other thing that we want to do is we want a collider on this. So let's look for a collider, a box collider. Okay. Now notice that our collider has this option called a material. A material is something that you can put around a collider to make it behave in a certain way in the physical environment. For this, we want our ball to be bouncy. So what we can do is we can go into our assets folder. Let's create a new folder called materials. And inside this materials folder, let's create a new physics 2D material. So let's go to physics material 2D. And we're going to call this bounce. Now this material, we have two options in the inspector. We have friction and bounciness. I'm going to set friction to 0 and bounciness to 1. So it has maximum bounciness. Okay. Now if we grab our ball object again, we can drag this bounce material into the physics material 2D to make our ball very bouncy. Okay. And I think that's all we need to do here. Now we can start writing the script. Let's go back to our scripts folder, right click, create a new script. We'll call this ball. And let's open it up. That was weird. Double click. Open it up. All right, so now we have racket and we have ball. Okay, so this ball script is going to be a bit more involved than the racket script because, like I said, this ball has a lot of different behaviors that it needs to represent. So let's do this. Let's create a reference to our ball. That's something we want to do right off the bat. Private, rigid body. And let's call it ball. Then inside the start method, we'll say ball equals get component, rigid body 2D. Okay. So now we have a reference to our ball. The other thing we need to do is we need to get our ball moving pretty much right as soon as the game starts. We don't want it to just hang there. We want it to move. So what we can do is say ball.velocity equals vector 2.right. And let's create a speed. Public float speed equals, and we'll say 30 for this as well. And again, we can adjust it as we go. So right times speed. Now you might be thinking, wait a second, I don't know if I want this to always move to the right. Maybe I want it to start moving to the left sometimes and to the right sometimes. And that's actually a good, that's a really important thing to think about because you want this game to be less predictable for your players. You don't want to give an advantage to one player over the other. But in order to make that happen, it would take a lot more than I think is worth to get into in this video. So we're just going to always have it moving to the right. All right, so this little bit is going to get our ball moving. Let's test it out and make sure that that works. First, we need to attach the ball script to our ball object. Let's drag that over. All right, now let's go ahead and get started. Let's hit play. And it works. And notice that because it's bouncy, it's actually bouncing off those paddles. It's not losing any momentum because our bounciness is set to 1 and our friction is set to 0. And it's doing exactly what we want it to do. We've started it moving to the right. It's bouncing off of the colliders. Okay. The next thing we need to do is we need to handle, basically when it collides with a racket, we want it to not just go back in the same vertical direction. We want it to reflect off of the paddle. And the way we want this to work is if it hits the top of the paddle, the top half, we want it to reflect in an upward angle. If it hits on the bottom half of the paddle, we want it to reflect in a downward angle, right? We don't want it just to constantly be going back and forth like this. We want it to give some bounciness and some, like, change the angle so it's a little bit more difficult to predict. So to do that in our script, we need to kind of think about some physics here. You know what? I'm going to get rid of this update method because I don't think we're going to need it. If we do, we can add it back in later. I'm going to get rid of this comment as well. All right. What we will need is a collision method. So void on collision enter 2D. Okay. Now, we also want to determine if we're colliding with the left or the right packet, or the left or the right paddle, right? Because we're going to change the direction in a certain way. We don't want it to collide with the left paddle and then have it shoot off that way, right? We want it to shoot that way. So we need to determine which paddle we've collided with. So in order to do that, we need to actually change our racket names so that they're easier to find in our script. So we'll call this racket left. That's my left racket. We'll call this one racket right. Okay, so now we have our separate rackets. That's racket right, that's racket left. Okay, so now in the script we can say if collision.gameObject.name equals racket left, meaning we've collided with the left racket, then we want to do something. Now let's think about what we want to do. Well, we want to take the position of the ball and the position of the paddle on the y-axis, and then we want to figure out where specifically the ball hit the paddle. And in order to do that, I think we're going to need a new method. Let's create a new method. And that method is going to do all that calculation for us. And then it'll return it back to this so that we know what angle we need the ball to move from. So let's create a float method. And what this method is going to do is it's going to return a float back to this other method. So we'll say float. Let's call it hit factor. That's a good name for it because we're figuring out where it hit. And it's going to need to take in a couple things. First, it's going to need to take in the position of the ball. So it's a vector 2. A position in 2D is a vector 2. And we'll call this ball pause for ball position. It's also going to need to take in the position of the racket. So we'll call it racket pause. And it's going to need the height of the racket. So we'll say, float racket height. I think that's all we need to do the calculations for this. Yeah, because we're going to do the positive value. Yeah, we'll do the position of the ball on the y-axis, and we will subtract it from the position of the racket on the y, which will give us their relative distance, and then we can do, we can divide the whole thing by the height of the racket. Yeah, that'll give us our exact position on the racket where the ball will hit. And if you're not following along, that's okay. We're just doing some physics math here. All right, so let's return ball pause dot y, so its position on the y-axis, minus racket pause dot, let's say y. Yep. Yeah, because we want the racket's position on the y-axis. And we're going to divide the whole thing by racket height. Okay. So that's what this method is just going to return the exact position that the ball hit the paddle. That's all we're doing here. Okay. So now back up here in our collision method, we can set our, let's grab a variable that will, let's create a variable that will grab the value of this hit factor. So we'll say float, we'll call it y, equals hit factor, and then we need to pass in those variables that it needs to do the calculation. So the first one is the ball position. So that's easy. That's just going to be transform dot position. Then we need the racket. So it's going to be collision dot transform dot position. Yeah. And then we need the size of the racket, which we can use. Oh, we can use the size of the collider actually. So collision dot collider dot bounds dot size dot y. So that looks pretty complicated, but basically all we're doing there is for this, we're getting the position of our ball. Then we're getting the position of the racket or the object we've collided with. Then in here, we're getting the size of the racket by checking the size of the collider, and we're getting the vertical size of that. Anyway, so all of that right there will produce a number. That's pretty much it, just a number. Basically, where I hit on that paddle. Okay, and then with that number, we can create a new vector 2. We'll call it dir for direction. And it's going to be a new vector 2. And it'll be 1 because we want it to go, we're hitting the left paddle, so we want it to go to the right. So we'll make it 1. And then we'll say dot y, or a y on the y. So this value, whatever this value is, y, dot normalized. It's basically going to do some math to make it a little bit smoother. Now, the reason why we're doing this as the y is because we're going to check to see if it's at the very top of the racket, then it's going to come off at a more extreme vertical angle. Whereas if it's in the middle of the racket, it's going to come off at a less extreme vertical angle, right? So if it hits up here, so if my ball hits up here, it's going to come off at a more extreme vertical angle. If it hits here, it's going to come off at a less extreme vertical angle. If it's dead in the center, it'll come exactly back, right? And the same down here. So that's kind of how we want this to work. All right. Let's see. Oh, and the only thing we need to do is change the movement of our ball at that point. So let's say ball dot velocity equals dir times, where's times speed. And that's pretty much it. And because dir is a vector, it's a vector 2, then we can just do it like that. Okay. I believe that's all we, nope. We did all this for the right, or for the left racket, but we need to do something else for the right racket. But luckily, all we have to do is copy. Let's copy this if statement, and let's paste it, and let's change it to racket right. And the only change we need to make is in this direction here. We don't want it to go to the right. We want it to go to the left. So we make this a -1. And that's literally it. That's the only change we need to make. This right here is our entire ball script. Okay. Let's save it. And let's come over here to Unity. Make sure that it's all come in properly and there are no errors. Let's go ahead and play the game and see if it actually works. So it's coming back. Oh, I can already tell it's coming off at a different angle. Oh, see, now this is already This is already Pong. It already feels like Pong. Now, there's an issue that we just noticed. If it hits the edge, nothing happens. We're not increasing our score. We're not changing anything. And notice that when it hits off the wall, it's not getting those extreme bounces. But I think that's probably good because we only want it to bounce extreme when it hits the paddle. That way it feels like the player has more of an effect on the ball. All right. Let's see. Let's check my time. We're at 30 minutes, almost exactly. Okay, so here's what we're going to do. I am not going to get into creating a user interface for this project. I am not going to get into creating sound effects for this project. I would recommend that you do that. Also, think about how you would set it up so that whenever this wall, the left wall, is collided, it gives this player, a point, and whenever you collide with the right wall, it gives this player a point, and then maybe in the user interface, you set it up so that you have your scores up here. That's probably something you want to play around with. But once you get it actually working, then you are pretty much done with this project. I would like to see some user interface stuff. I would like to maybe see a main menu. Whatever you want to do, expand on this as much as you want. But that's going to be it for me. So I've shown you how to build the base game. I've shown you how to do the programming. Now it's on you to make changes and additions and make it look really cool. All right. Thanks for watching, and I'll see you next time. Bye.